Hey, Nathan here. Welcome back to another Tower Defense Engine tutorial from PH Studios. Last tutorial we discussed the map loader class and got that finished, and that started that big chain of loading that we have talked about since the very beginning. And now we're gone to part 2 of the bullet class. So part 2 of all these classes, and some of the classes like the map class and the user interface classes, they might require part 3 and part 4. But these next parts are all the more interesting coding, the actual meat of the engine and how it's going to work. We call these methods, but they are blank, so the actual code to do what we want the game to do, we'll be discussing that in these parts. So the first up is the bullet class, and we're going to go, we already did everything in the past. We got all the fields and properties and writers and readers. So now what we're going to do is the methods, the actual bodies of the methods. Now these were brought in from the gameplay object class, so I just copied and pasted those. So those method bodies are fine, and I can go ahead and click this little minus symbol. Alright, so let's start from the top bottom, and let's start with the initialize. Alright, so initialize is just going to get everything all set up and get all of our textures, all of our sound effects, anything we need loaded into our memory, and it'll just it'll set the states of the objects and all that stuff. So first thing up is the texture of the bullet. So texture is equal to content manager.load less than, it is a texture 2D object, greater than, opening parentheses, string.format, opening parentheses, double quote, textures, double backslash, maps, double backslash, opening curly brackets, 0, closing curly brackets, double backslash, bullets, double backslash, opening curly brackets, 1, closing brackets, curly brackets, and then end the double quote. Now this is the path for where our bullet texture will be. If you want to make your own folder structure, you can, but this is how it's going to work for my game implementation, and I'll show you that right now. So here's the completed code, and that's what I'm basing this off of, but I can go into the actual content here. So let me bring this down here, and I can show that. So we're going to the textures folder first, and then we're going to the maps folder. Now, what we need to do now is find out which map we're referring to, and that's what that opening bracket 0 closing bracket is for, because we'll pass it the map name. So each map has its own set of textures and anything like that. So let's say the forest map. We want to load the bullet for the forest map. So we open up forest, and that's what the bracket 0 bracket's going to be. Then we go to the bullets folder, and then we have our bullet name. Is it the pebble or the particle? So that's what that long path is for. You can have your own path structure. If you want to change this, just change the way that this works. But that's totally up to you. Alright, so let's add a comma back into the code here. And now we'll pass in the map.name, and then comma, texture, asset, closing parentheses, and semicolon. Alright, now I'm going to press enter key here so it stays on the same window. Now we're going to set the origin is equal to new vector2 opening parentheses, the texture we just loaded, dot width divided by 2, comma, texture dot height divided by 2, closing parentheses, and semicolon. Now, all this origin does is it says that the origin is in the center of our texture. So when we do our rotation and scaling, it will use that as the center point. Every bullet, whenever it hits a monster, is going to throw a particle system. Now that particle system needs textures in order to display the particles. So that is being handled in the bullet class, and it's the particle texture. So particle texture is equal to content manager.load less than texture 2D greater than, and we're going to load the same path that we have here, opening parentheses, string.format, opening parentheses, and load the exact same path, comma, map.name, except for instead of texture asset, it's going to be particle asset. Closing parentheses, and semicolon. So the particle texture is loaded the same way that the texture is, except for instead of passing texture asset, we pass particle asset. It refers to the same folder, so the same folder path, and we pass it the map name just like the same as texture, except we're passing the particle asset. Alright, now our graphics and origin are set. Now the only thing left is to set the state is equal to bullet state.inactive. Our bullet is inactive. Okay, so that's it for the initialize method. We just got our textures loaded, the origin set, so when we rotate, we are using that as the point of rotation, and then the particle texture, that's for when it hits the monster, it'll throw those 4 particles, and then we set the state. Alright, next up is the update method, and we'll perform a certain section of code depending on what the state is. That's the whole point of the states. So if the state is active, we obviously need to update its position, just like a normal bullet. If we hit the enemy, we need to throw the particle system, or if we already have the particle system, we need to update it. Alright, so we're going to use the state. So if state is equal to double equals bullet state.active. If our bullet is active, position plus equals vector2.multiply. We have a velocity, so we multiply velocity, comma. We need to cast as a float the game time. Game time dot elapsed game time dot total seconds times. Going back to the user interface, when we have the command info bar on the far right side of the screen, at the very bottom you'll see we can pause, increase speed, and decrease speed. Now that's going to be a global set. Now I could change the game time and only do it once. However, if you ever want to have a special ability or something, if you want to give some tower or some part of the game access to operate at the same speed no matter what you set it as, we are going to do this as an individual basis. So in order to get our current game speed, we have that in our session object. So in order to get the session object, this is why we have singletons here. Session.singleton.speed. So that is our current game speed. Now, if you want to change this to where it will only affect, you'll change game time once and then send it to all the other classes, that's fine. I'm just doing it as an individual basis for in case I want something to remain 100% speed. Okay, now that the position has been set, and I'm going to press enter before session.singleton.speed, so I don't have to have that horizontal scroll here. Alright, so the position has been updated. Now we need to calculate the bounding rectangle. So we open in parentheses, and now it needs a matrix transform, and that's being handled by the calculate matrix method. So opening parentheses, closing parentheses, and semicolon. So we need to calculate any time our position is changed or our scale or rotation has been changed. So anytime we update any part of our bullet, we need to calculate a new bounding rectangle. And we have a matrix because we can have a scale or rotation or anything like that that might need to adjust our bounding rectangle. Okay, so now we need to check collisions. So the bullet will check collisions based on the monsters. For each monster M in owner dot map dot active wave dot monsters, opening curly brackets, closing curly brackets. So this is why we need to get everything, all of our properties and all of our methods finished before we did part 2. Because everything will call a certain set of, right now we're calling the owner, which is a tower. And that calls map, which is the map class. And that refers to an active wave, which is a wave object. And now we need to have a list of monsters to gain access to do our for each loop. So the way I organized this as I was starting development is I created all my properties and method headers, just like we did in the tutorials. And then I went back and did the method bodies, just like we're doing now. So for every monster inside of the active wave monsters list, so all the monsters on the screen or are currently waiting to be spawned, all those monsters need to be checked for collision. If, which brings me to the next part, if M dot is active, if a monster is waiting to be spawned, it is not active yet. So if the monster is active and our rectangle, remember we updated our rectangular bounds, so and rectangle dot intersects, opening parentheses, M dot rectangle, closing parentheses, opening curly brackets, closing curly brackets. We need to set the state to bullet state.hit. Our bullet has hit the enemy. We need to call the hit method, so capital H and hit, opening parentheses. We need to pass the monster that has been hit, closing parentheses, semicolon. Now, we only have one bullet. Our one bullet has hit one monster. We do not need to check any more monsters, so at this point we can do a return statement here. So we could have hit the first monster we checked, and we could have 20 other monsters inside this list. We don't need to check 19 more times, so we can just do a return here. So that is when the bullet state is active. It updates the position, it updates our rectangular bounds, and it checks for collision. Now, when it has a valid collision, it changes it to a bullet state as hit. So else if, opening parentheses, state is equal to bullet state.hit, opening curly brackets, closing curly brackets. So I put this else if after the if, of course. And inside of the else if block, we need to test if the timer, we have a timer for any time we need to have something happen in a certain set amount of time. In this case, it's the particle system. So the particle system will spawn, and then we'll let it go for about half a second or however long you want it to go. And after that, it'll set it to the state as bullet state.inactive. So it's an inactive bullet again. We can use it later. Else, opening curly brackets, closing curly brackets. So if the timer is still going on, we need to decrease the timer. Timer minus equals, we need to cast float the game time dot elapsed game time dot total seconds. Then we need to multiply by the session dot singleton dot speed. Then we have a semicolon here, and we press enter, and we need to update the particle system dot update. We need to pass it the game time. For example, the particle system does not obey our session singletons, our speed, our current speed of our game. The particle system does not obey that speed restrictions or speed increase. The particle system always operates at the same speed. So that's one of the reasons I did not change the game time globally. Okay, so that's it for the update method. We have two states that we had to perform different tasks for. Alright, next up is the fire method. Now, every tower is autonomous, which means once it has a valid target, it will rotate and it will point towards that target. And when the timer reaches a certain value, it will fire. And it will call this method here. So it'll pass who fired this bullet. So we need to set that up as the owner. So owner is equal to T. Now we need to set the position. Position is equal to new vector 2, opening parentheses, the tower's T dot position dot X, comma, T dot position dot Y, closing parentheses and semicolon. So the position is going to be equal to the tower's position. Velocity is equal to new vector 2, opening parentheses, the speed of the bullet, not the session, not our singleton speed, not this speed here, but the speed that our bullet can operate, times, we need to cast as a float math.cosine, COS, capital C, opening parentheses, the towers, so T, dot rotation, closing parentheses, comma. Now we do the same thing, speed times cast as float, math, but right now we're going to use sine, capital SIN, opening parentheses, T dot rotation, closing parentheses, and semicolon. This is vector math where we have the length of the vector, the speed, and we have the rotation. Now we need to build the vector given those two values. We have the speed and the rotation. We can build the vector given those two values. Now I have a vector math PDF that you can view, or I've a tutorial from the basic training series that covers vectors, if you want to check those out. But this will set the velocity, and it will set it to go the same direction as our tower's rotation. Alright, now the rectangle. When we have the bounding rectangle, we need to set it up the first time. New rectangle, opening parentheses. We need to cast as an int. Position.x, comma, cast as an int. Position.y, comma, texture.width, comma, texture.height, closing parentheses and semicolon. Now we set the state is equal to bullet state.active. Our bullet has been fired, so it is active. Okay, next up is the hit method. Now just above in the update method, we did a check for collisions. When we have a valid collision, it will call the hit method, and it will pass the monster that was hit. So let's go ahead and create the code for that method here. We need to set timer, and we need to give it the maximum time for our particle system. And we have that by die time. Timer is equal to die time. Now the monsters do not check for collisions. That is the bullet's job. Now when we have a valid hit, we need to call monster.hit. And we need to pass it this, the bullet that hit that monster, comma, owner, the owner of the tower, or the owner of the bullet, so the tower. Closing parentheses and semicolon. So since the monsters do not check for collision, it's up to the bullets to do that. And then it's up to the bullets to call the monster's hit method and pass it the bullet that hit it, as well as the owner of that bullet. Okay. If type is equal to bullet type.aoe. If the type of the bullet is AoE, area of effect, we need to call perform AoE attack. Opening parentheses, the monster that we need to perform the AoE attack by using that as the radius point. Closing parentheses and semicolon. Now we need to have an else if type is equal to bullet type.dot. Damage over time. If it is damage over time, we need to call m.apply dot. Opening parentheses, we need to cast as int. Opening parentheses again. Owner dot current statistics dot damage times dot damage percentage. Closing parentheses, comma, dot time. So for my implementation of the game engine, the damage over time is a percentage. So if we do 100 damage every time we hit a monster, when we have a dot bullet, we could possibly do 10% of that damage over 5 seconds. Which means in 5 seconds it would have dealt 10 additional damage on top of the 100 damage. So at the very end of 5 seconds it will have achieved 110 damage to that monster. Alright, so that is the two special effects, and in a later patch we will delete these and actually use the ability folder here. Okay, so that's the effects that we need to bring to the monster. Now we need to bring in the particle system. So particle system is equal to new particle system. Particle system dot system timer is equal to timer. I'm going to go ahead and copy the word particle system so I don't have to type it every time. Particle system dot particle longevity is equal to timer. Each particle will last the exact same time as the system timer. So we will not have particles spawning and disappearing throughout the lifetime of the particle system. The 4 or 6 particles that you see whenever the bullet hits, those are the same particles that will be there when the system goes away. We will not have new particles spawn, and we will not have particles disappear before the timer is done. Particle system dot birth rate. The birth rate of the particles. Here you can, that is particles per second, which is obviously 0 because we do not want to spawn any more particles. Particle system dot initial particles. And here you can set it to whatever you want to choose. 4 particles, 6 particles, I'll choose somewhere in between and say 5 particles. So anytime our bullet hits a monster, it'll spawn 5 particles, and then that will be it. Particle system dot texture name is equal to particle asset, semicolon. Particle system dot birth revolutions is equal to 0. Particle system dot death revolutions is equal to 8, semicolon. So what this will do is it will rotate our particle from 0 to the 8th revolution in its lifetime. You can increase this to make it rotate faster or decrease this to make it rotate slower. At the very end of our particle system, we need to call .initialize. We got all of our properties set up, now we need to call .initialize. Okay, so the particle system object is only half the battle. We need to have an emitter for the other half. And the emitter is responsible for throwing the particles. It gives them the velocity, it sets their position, it's responsible for spawning those particles. We do not have any particles spawn per second, but we do have 5 initial particles that will be using the emitter to spawn those. So we need to have an emitter for those 5 particles. So emitter is equal to new emitter, opening parentheses, particle texture, closing parentheses, and semicolon. Emitter.radius is equal to new vector2, opening parentheses, 0, 0, closing parentheses, and semicolon. Now, I use this as a template for later use. If you always want to use vector 0, there's a quick way you can do that called vector2.0. But, in any case, if I want to change the radius, I can just change these values here. I can make it completely customizable too in the XML by having these as variables. Emitter.position is equal to position, our bullet's position. Emitter.velocity is equal to new vector2, opening parentheses, velocity.x divided by 5.0f, comma, velocity.y divided by 5.0f, closing parentheses and semicolon. Now, why did I choose 5.0f? It's just what I thought looked cool. I want to limit the velocity of the particles by a certain amount, so I decided to divide it by a certain value that I choose. So I divided it by 2 at first, but it was still a little bit too fast. Then I divided it by 4. It was just about perfect, and then I decided to try 5. And that, to me, was perfect. If you want it to move slower, you increase this 5 to 6, 7, or whatever value you want. If you want it to move faster, you decrease the 5 to whatever you want. Emitter.velocity.normalize. We're going to normalize the velocity. Now we need to set particle system dot emitter is equal to emitter. So that way the particle system will use that emitter that we have created. Now the particle system is a custom library I set up. We did this in the first video where we brought in the particle system.dll and we added to the references. So it's a custom system I set up for myself, for my games, and then I customized it even farther for the tower defense. There are a few things that I wanted to have just for the tower defense that I changed in the particle system library itself. So there is a particle system project that you can download from Subversion, and I did a particle system video for the networking series, and I did a particle system usage video that you can look at. But this is a little bit of a different functionality that's just for the tower defense. Okay, so next up is the perform AoE attack, and that's the area of effect. Now for AoE, it's gonna hit every monster within a certain radius. So for each monster, m in owner.map.activewave.monsters, closing parentheses, opening closing curly brackets. Now that's going to loop through every monster inside of that list. Now if the monster we're looking at, so if m is equal to the monster we passed in this method, we do not want to do anything to that monster because that's a monster we have already hit. So if m is equal to the monster we have already hit, we need to continue, which will do the next iteration of this loop. Float distance is equal to, opening parentheses, new vector 2, opening parentheses, position.x minus m.position.x, comma, position.y minus m.position.y, closing parentheses, dot length, opening and closing parentheses, and semicolon. So we just need to calculate the distance from our current monster, our bullet, which is the point of impact, our point of collision, and the distance from that point of collision to the monster we are looking at in this iteration. Now if that distance is less than or equal to our AoE radius times session.singleton.map.tile dimensions.x, closing parentheses, opening and closing curly brackets, m.hit, we need to hit the monster again, this, comma, owner, closing parentheses, and semicolon. Now let me talk about this little if section here. Now our AoE radius will be something like 3. And that will be 3 tiles is the radius of our area of effect. So we need to take that 3 times our actual dimensions, so our actual tile dimensions. And that will give us the actual our actual radius. Alright, last method is the draw method. This is a pretty simple one. If the state is equal, double equals, bullet state.active, we draw the bullet. Sprite batch.draw, opening parentheses, the texture of our bullet, comma, rectangle, comma null, color.white, comma rotation, comma the origin of our object, comma sprite effects.none, we don't want to flip it in any way, comma 1.0 f, closing parentheses and semicolon. Alright, so now we just draw the entire texture, and that was what that null was for. It draws the entire texture, and it draws it at the specified rectangle with the color white, rotation, and origin. Okay, if it is not active and the state is bullet state.hit, we need to draw the particle system instead of the bullet. So particle system dot draw on existing sprite batch cycle, opening parentheses, game time, comma sprite batch, closing parentheses and semicolon. Now check out one of the particle system videos and you'll understand why this method exists. That is one of the things I customized the particle system for this tower defense game so it can draw on the existing sprite batch cycle. The way that the particle system originally operated is it has to be in its own sprite batch cycle. What a sprite batch cycle is when we call sprite batch.begin and sprite batch.end. I refer to that as a sprite batch cycle. Whatever in between the begin and end is the cycle. So the particle system by default operates, it needs its own sprite batch cycle so it can set its own blending state and its own effects to the sprite batch. And I had to add a way to draw the particle system on the existing cycle for such a game as this. Okay, so that is it for this class. You can save it and we can put this class behind us. Everything is complete. And we're ready to go, and we'll start the monster class part 2 in the next video. So I hope you enjoyed this tutorial, and I'll see you next time.